Chapter 6 builds on Chapter 5. It uses probability to deal with random variables. And I guess I should start with the definition and meaning of random variable. A random variable is a chance process that can result in any one of several results. A random variable could be the gender of your first child. It has a 51% chance of being female, blah blah blah, different results, and the probability of each result of happening. But Chapter 6 is going to deal with quantitative random variables. And we're going to start off with, that means number values results. Male, female are not number results. The lottery is a good example of a random variable. I have no idea what the result of buying my next $2 scratch ticket is, but here are a bunch of possible results and the probability of each one happening. This is going, if you think about Chapter 5, we dealt a lot with two-way tables. That's very sort of qualitative, categorical yes or no, success, failure, did I offer you a job or not, sort of things, which, while now we're going to deal with both discrete random variables, where there's a set number of possible results and the chance of each one happening, and continuous, like the normal distribution, where there's where we wouldn't say there's a probability of a specific result, but there's probabilities of being in any particular range. So let's start with this example here. This is a discrete quantitative random variable. So it's a random variable, there's a whole bunch of possible results, and the probability for each one. It's discrete, so there's a few key possible results, and there is no result that involves winning $2. You could lose $2 because you pay $2 for the ticket. You could earn $18 because you pay $2 for the ticket and win $20. You could win $98 because you paid $2. It says you win $100, but you paid $2 for the ticket, so this would be the overall result. And the chance for each one, there's a few specific results, so that's discrete as opposed to continuous. There's no chance of any value somewhere in between them. Yeah, random variable, what did I say? Discrete quantitative, so all the results are numbers, not things like male, female. Alright, now, what do I want to say about this? We can do a few things. I can ask you, find the probability that the result will be, that the result of this random variable, which I'll call L for lottery, probability that the result of doing lottery will be less than $100. Well, what's the probability that you will win less than $100? You would add together the chance of winning 98, the chance of winning 18, and the chance of losing 2, and that would be the probability of that. You may see a question or two like that. But we're going to be concerned with something called expected value. Expected value is what you expect your result from playing the lottery is going to be, whether it's overall to win money or overall to lose money. Spoiler alert, you're going to lose money. Expected value is very closely related to the idea of probability from the last chapter. In the last chapter, probability meant how often you think something will happen in the very long run. That's a very sort of categorical way of looking at it. How often will something happen? Expected value is how much do you expect you will gain or lose over the very long run. Well, if you keep playing the lottery, you will eventually lose an infinite amount of money, so that's not a useful thing to think. But what's the average result you will get over the very long run? That is useful. It has a lot of uses in insurance. You may win, like the insurance company may win sometimes because the person doesn't die till they're 90 and they make payments on their life insurance that whole time, or the person never gets robbed. So the insurance company wins because they bring in lots of money from the homeowner's insurance or whatever, and they never have to pay out. There's the probability of that. There's the probability, but then there's some people who will get robbed and you have to pay them back. So expected value is used because if you figure on average you will gain over the very long run, well, if you have 500,000 customers, then you have a very long run. So expected value is useful for calculating if you kept going what you would expect. Is it a good deal or is it a bad deal? Let me put it to you this way. Let's say we play a game where we flip a coin twice. And if I get 2 heads, I will pay you $100. And if we get anything else, you will pay me $2. Well, let's consider that. You could gain $100 with a probability of 0.25, or you could lose $2 with a probability of 0.75. Well, you're more likely to lose money than to gain money, right? So you should definitely not agree to play this game with me. That's nonsense. The amount you're winning would be so much bigger. If you could play this game several times, if you had many opportunities like this, then overall you would win. Is it worth it to play this game? Absolutely, because on average, if you were to be offered many other opportunities like this, you would gain money. Now you might say, but I only have this one opportunity, right? And I'm probably going to lose money. But that's nonsense, because over the course of life, you run into many opportunities. And if you always avoided these, any opportunity which was more likely to fail than to succeed but had a bigger reward than loss, then you would miss out big time. So we calculate expected value to get a feel for what, on average, the result of many such possibilities would be. In the case of this game where double heads earns you $100 and anything else earns you pay me $2, well, you have a quarter chance of winning $100. So what's a quarter of 100? 25. And what is 3/4 of a loss of $2? Loss of $1.50. So the ability to play this game, the offer of playing this game, is worth $23.50. You definitely shouldn't turn it down. It has a positive expected value. Let's consider the lottery, which is a more comprehensive example. Right? You have a very small chance of winning very large prize money, and you have a very large chance of losing very small amount of money. The way that they know what to make their probabilities in the lottery is they make sure that any player has a negative expected value, so it's not worth it for them to play the lottery. People are interested in that very small chance, but overall the lottery will bring in more money than it pays out. Otherwise, why would they exist, right? They want to make sure that their positive value, their expected value, is positive and your expected value is negative. If I was going to calculate the overall expected value, the way to calculate expected value of lottery, oh hell, I'll just use X. They always use X in all the textbooks, and they use let's call this lottery result. Playing the lottery will be defined as X. The result of playing the lottery. The expected value of that action would be, well, let me show you the formula from the book and from your formula sheet. The way they write the formula, they say the average result of playing this game is the expected value of playing this game, which is the first result times the probability that it would happen. So if you have a 99% chance of losing $2, that would mean 99% of $2, a loss of -2 times 0.99, negative 1.98. So if you lose $2 99% of the time, that means that you're basically losing in the very long run $1.98 per game from that. But then there's also the second event and its probability to, 2, x2 and p2, the second event times its own associated probability, which would be, this way, and then you'd have positive point, I want to say, 162. So the almost 1% chance of winning $18 is worth 16.2 cents per game, plus that, which basically moves it over twice, and you're going to have like 0.08 something. The point is, if you add all of those together, you will get the expected value of playing the lottery ones. and if I did a good job of this, which I hope I did, then the expected value will turn out to be negative because on average you will lose more money than you gain if you play the lottery. I hope I designed this right and it comes out negative. Check it yourself. See if it comes out negative. And I think this is a good place to pause for now.